Hello, quadratic graphers. Let's explore what it means to graph a quadratic equation and all the different interesting parts of those graphs and the equation and how they relate. So first, let's remember what it means to be a quadratic equation. Means that the power, the highest power of x in this case, is going to be a power of 2. So the simplest quadratic equation, of course, type in here is y equals, and why do we have no graph there? There's the graph for it. So you can see it makes this U-shaped, which the correct term, of course, is parabola. It makes a parabola. And if we zoom out, you can see it just going, going, going. And that's your most basic quadratic equation graph. A simple parabola that goes through the origin here and goes up. And you can see it makes sense, right? You know, what are we saying? Y equals x squared. Any value of x, y is going to be the square of that. When x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. So it's going to go up faster. It's going to make that curve, and the negatives are all going to be the positive versions of the negative number squared, right? Negative 2 squared is 4. Negative 4 squared is 16, etc. So what happens when we change this? Over here, let's put in a coefficient of 2 and watch what happens. Oh, how about if it's 21? Whoa! Okay, I'm going to put an extra 2, make it 212x squared. So obviously it gets narrower and narrower, which makes more sense. Whatever was the value of x has been then multiplied by our coefficient, and therefore the values go up faster. Alright? How about if we therefore make this into a number less than 1? Say 0.5. It's hard to tell what happened there. But let's put a 0.05. Whoa, you can start to tell what's really happening. It's flattening out because, of course, we're multiplying the values by a decimal point that's going to make them smaller. Right? So it flattens out or gets steeper based on the coefficient of the x squared. And what if it's a negative coefficient? Let's make it a negative x squared. Whoop! Take that away. Whoop! Put it back. Whoop. Negative x squared, x squared. Negative x squared, x squared. Let's put this in the middle. Negative x. Ooh, I lost my. I think you pretty much get the idea. What happens if it's negative? It's negative 2, gets narrower just like before. Negative 23 gets narrower still. Alright, so the negative versions, the parabola turns down. And you can kind of think of it as negative is a sad thing, and therefore looks like a sad face. And a positive is a happy thing. There we have a smile. Smile. Negative is frown. Alright, fairly simple. What happens when we add, let's just make it the simplest. Let's just add a number, a coefficient. A constant. Let's add a constant to our x squared. And what happens if it's x squared plus 2? It's hard to tell quite what happened, but the difference between what we had it before and plus 2 is that it was raised 2 units, just like a linear equation. This value here, not only is it just like the linear equation going to be the y-intercept, because 0, when you put it in x is 0, you're going to be left with the y equals 2, but therefore it's going to raise the value. So likewise, if it's a negative, it's going to raise the entire graph. So if it's a negative 2, it will lower the whole graph, right? It makes total sense. And then a minus 5 is going to lower it even more. So those are the two main aspects that we want to understand. What happens because of the coefficient of the x squared over here, and what happens because of the constant at the end. But of course there's also the b in the ax squared plus bx plus c standard form. And so let's just look at that a little bit. What happens if there's an x in here? Well, if there's just an x in here, it changed a little. You can see it moved a slight bit over to the side. actually it went at an angle, and we can see that better if we put a larger value. You can see it actually shifted down. And if we make an even bigger value, let's make it a 2.9 for example, you can see it continues to shift down and to the left. And if we pull those back, we come up. Let's see if we can take rid of that. And what happens if it's a negative x? Oops, come on down. It went down and to the right. And we can change that negative to a -2, and you see it continues to go lower down. And let's say it's a -2.9, we can see it continues to go down. Right? So what's going? It's going at an angle to the side, and it's pretty interesting if you want to explore how far it goes down and over, or down and over. But it's not something that we have to concern ourselves too much with now, so I'm going to let you explore that. What we really have to understand is that the a value, the coefficient of the x squared, if it's a positive, then you have a smile, as I said. If it's a negative, then you have a frown. It opens downward. And as the number gets larger, then the graph gets narrower. As the number gets smaller in terms of closer to 0, then the graph gets flatter or wider. And our C shifts the graph up or down depending on the value of it, with this B here also adding an extra shift to it. And finally, this C value is the y-intercept. And that's part of what, when you think about what's happening with the B and it's going over and down or over and down, that's part of what's going on, why it ends up where it is this still has to tell us the y-intercept. And when you're exploring that B, you also want to look at what happens if we had a negative value. Ooh, you notice it did not have the same vertex point. When I put a negative in here, it changed the vertex point but kept the same y-intercept. Okay, that's an interesting point, because let's go back to here. Right here, if I change the y, it does simply flip, right? But when we have something else, we have an x, then it's actually rotating around that y-intercept. Whether there is, I don't know if you can tell it, there's a rotation going on there. Okay, again, things you need to know are about the A and the C. And of course, we also need to look at, where the graph crosses the x-axis. That's interesting. And this vertex point, those are all very interesting points about the parabola that we're going to talk more about. See you in class.